Okay, welcome to lecture number 3, testing of materials, non-destructive testing. So in the last lecture number 2, we have seen the mechanical testing, and here we are going to see the NDT, that is non-destructive testing. So the overview of NDT testing is like, we'll be analyzing by using some machines. Instead of giving the force directly to the material, so we'll be using some machines to identify the flaws or bubbles created inside the materials. Okay. So the non-destructive testing is a testing and analysis technique used by industry to evaluate the properties of the material, component, structure, or system for characteristic differences or defects and discontinuities present inside the material. So NDT, also known as a non-destructive examination technique, non-destructive inspection, and non-destructive evaluation. Okay. So the importance of the NDT is like to prevent accident, to determine the acceptance to the given requirement, to give information on repair criteria, to ensure product availability. So these are the importance of NDT. Okay. And the stages for the stages for performing the NDT test is like, first we have to test the sample, like we have to prepare the sample first. We have to apply the dye or some dye in case of liquid content, and AC source in case of electromagnetic testing, and mechanical loading in case of other loading tests. And we have to have probe, receiver, etc. And the next one is recording and reporting the modes of output is displayed in computer. Okay. So what are the things we are recording will be displayed directly to the computer. And finally we have to interpret and we have to find the result of the material. So these are the steps we have to carry it out. We have to carry out for doing the NDT test. And first we have to do the testing, then recording, reporting, interpretation, evaluation, NDT procedure. Okay. So these are the procedures we will be following to be the NDT. So NDT testing methods are classified into mainly uh, 8 types, that is acoustic emission testing, electromagnetic testing, ground penetrating radar testing, leakage testing, liquid penetrant testing, magnetic particle testing, radiographic testing, and thermal or infrared testing. And the material factors that affect the visual testing is, so this visual testing is nothing but another kind of testing by monitoring the material with our naked eye. Okay. So for that we have to prepare the specimen. So the first step you have to do is you have to clean the specimen. Then in case if it is a dye penetration test, you have to inject the color. Then we have to identify the tester, physical conditions, specimen conditions, shape and size of the test. So the advantages of visual testing is like, it is a simple method. So by our naked eye we can inspect the material, so it can be performed very quickly, and it is also a low cost method. And the next one, the disadvantages of this technique is like, we need training to the inspector. Okay, so the person is going to inspect and material, means we have to give training to him, and after the training he can able to perform the operation. So without training we can't able to do. So these are the some of the disadvantages of the visual testing. And the person should have a good eyesight, and so if the eyesight is not very clear, then he may be missing some internal defects. And the other disadvantages are like, the human error is common, so some human error may happen. So these are the some of the disadvantages of the visual testing. And the next one is it is the thermographic testing. So in this thermographic testing, what we are doing is so this is the specimen. So in this specimen, we will be heating this specimen by means of some kind of furnace, and so the material will be heated, right? So if there is any flaw in the material, so that portion alone will not be getting heated. Okay, that thing we can monitor by using an infrared camera. So this infrared camera, it monitors the material for heat, and if there is any flaws or bubbles inside the material, we can easily identify the uh, defect in the material. Okay, so this infrared camera is directly connected to the computer. So from this computer we can easily monitor the uh, material, whether it has any defects or flaws inside the material. Okay, so this is about thermographic test. So this infrared testing and thermographic test uses a sensors. We know it emits infrared light to assess the condition of the material. So the thermographer, it captures the thermal conductivity of the material and it sends directly to the computer for monitoring. The next one, it is the radiographic testing. So this radiographic testing is a non-destructive testing. It uses X-rays. Okay. So by using these X-rays and gamma rays, we will be identifying the flaws present in the material or specimen. Okay. So here X-rays are used for small materials and gamma rays are used for very hard materials. Okay. So here from the diagram itself we can able to identify. We have placed the test specimen on the table, and and X-rays are used for identifying the flaws present inside the specimen. Okay. So here we have used gamma rays because this material is very hot material, so that's why we are going for gamma rays. Okay. So this gamma rays passes through the specimen and it reaches the film, and from the film we can able to identify the material flaws present in the specimen. The next test, it is the ultrasonic test. So here the same thing. So instead of X-rays or gamma rays, we will be using ultrasound for measuring the measuring or detecting the flaws present inside the specimen. Okay. So here the ultrasonic transmitter, it transmits the ultrasound, and that ultrasound goes into the material and it comes out to the receiver. So while it is going into the material and it comes out, if there is any flaw inside the material, so it directly detects and it gives the signal to the computer. So by using this we can able to easily identify the flaws present inside the specimen. Okay. So the ultrasound test is a non-destructive testing technique based on the propagation of ultrasonic waves transmitted into the material to detect internal flaws or to character materials. The sound frequency is used to perform ultrasonic testing with the range of 20 MHz and the wavelength in the range of 1 to 10 millimeter. Okay, so this is what we'll be doing in the ultrasonic testing. So that's all about non-destructive testing. Thank you.